So good afternoon. We're going to try to throw in one-step inequalities. Okay? So these aren't equations, these are inequalities. A little bit different. Remember the inequality symbols. One of the symbols we're familiar with is the symbol is less than. This is our is greater than symbol. I don't know if you've seen these yet, but this is considered is less than or equal to. It's actually a compound statement. It means less than or equal to. So it's got two things going on. And this is greater than or equal to. So it's got two little conditions on it. So you can be greater than or equal to. Those would be the conditions. So looking at this inequality, I have 8 is greater than a negative 4. Notice again, that is a true statement because we know that on a number line, I have 8 over here and negative 4 is over here. And we know that if you're comparing numbers, the number to the right is the larger one. And we know, of course, that a positive number is always greater than a negative number as well. So we know that that's a true statement. Now, with the equations, remember to keep that equation balanced, we were allowed to do the same thing on each side of the equation. Well, inequalities have some of these characteristics as well. Notice that, for instance, if I change this to 8 plus 2 is greater than negative 4 plus 2, in other words, if I add the same number to each side, let's see what happens here. I have a 10 is greater than a negative 2. Well, is 10 greater than a negative 2? Yeah. So what this means is, since 10 is greater than negative 2, I still have the truth is still there. I haven't changed the truth. It's still a true statement. And that's what's important here. So we've got to focus on the truth. It has to be a true statement, not a false statement. Similarly, I have the same inequality. Suppose I subtract 2 on each side. So I have 6 is greater than a negative 6. Is that still a true statement? Yeah. So subtracting the same number on both sides does not affect the truth. It's still going to be a true statement. So we're allowed to subtract the same thing on both sides. Next example I want to look at is, we know we've played with addition and subtraction. Let's talk about multiplying and dividing. Let's divide this by a 2. So that's going to change to 4 is greater than a negative 2. Well, is 4 greater than a negative 2? Yeah, a positive number is still greater than a negative number, so that has not changed anything. So we're still okay here. My last example, and of course notice I have a little asterisk here, so something's going to happen here. What I'm going to do this time is divide by a negative 2. So if I divide by a negative 2, that's going to change to negative 4 is greater than a positive 2. Is a negative 4 greater than a positive 2? Negative numbers are not greater than positive numbers, are they? So this is wrong. This is not a true statement. So what we pick up on is this little conclusion here. If each side of an inequality is multiplied or divided by a negative number, if each side of an inequality is multiplied or divided by a negative number, what we want to do, if this happens, we want to flip the inequality symbol. So if I find myself dividing each side by a negative number, I can't leave that inequality symbol like it is. I must reverse its direction or flip it. So if it's a greater than symbol, I got to flip it over to a less than symbol. So in a scenario where you multiply or divide by each side by a negative number, to keep the truth, I have to flip that inequality symbol. And now it's a true statement. So that's going to be really, really important as we move forward. Watch out for that little scenario. So what we're going to pick up on is playing with inequalities is going to be a whole lot like playing with equations, but there's that one little exception. If you multiply or divide both sides by negative, that inequality sign has to reverse directions. It's got to flip. Okay? So let's see if we can put that into action. Stay tuned.